Hello folks, Miss Roll here with our types of chemical reactions number 2 notes video. So again, our objective is to identify the different types of chemical reactions. If you have not already watched part 1, please make sure that you go do that first. That'll make a little bit more sense if you have watched part 1 first. So first of all, what are single replacement reactions? We're going to talk about the different replacements, starting with single here. So single replacement. A single replacement reaction is when the element replaces another element in a compound. So one thing replaces another single thing in a compound. So the reactants are going to be an element and a compound, and the products are also going to be an element and a compound, but they've kind of just switched partners. So an example here would be zinc and iron chloride, FeCl3, react to form iron and zinc chloride. So notice how that iron and zinc have kind of swapped places. In our picture here, we've got the Flintstones, right? And our two lady cave people are switching partners here. Kind of think of it like a dance, like switching who you're dancing with. That's a single replacement. The thing you can always notice is we've got an element by itself and then a compound on both sides. That's going to tell you we have a single replacement reaction. So a couple other examples. Here we have Na and CuCl2 reacting to form Cu and NaCl. Again, we've got that single element on both sides and a compound on both sides, and that single element and one of the things in the compound are kind of switching places. Single replacement. Another one, we have Mg and AgCl reacting to form Ag and MgCl2. Again, single element on both sides and a compound on both sides. And it's just what's single, what's by itself is switching. Okay, that tells us it's a single replacement. So what are double replacement reactions? So these are where elements from two different compounds kind of replace each other. Okay, two different compounds replacing each other. So you're going to have two compounds for the reactants and two compounds for the products. Okay, so when you see something that complicated, you can think in your head that it's going to be a double replacement reaction. Here's an example. We have AgNO3 and NaCl reacting to form NaNO3 and AgCl. You can see they've kind of swapped places again because over here we had the Ag with the NO3. Now the Ag is with the Cl instead of the NO3, right? And here the Na is with the Cl. Now it's with the NO3 as instead of the Cl. So all those things kind of switch in spots. So again, here's some examples. We have NaCl and CaSO4 reacting to form CaCl2 and Na2SO4. So again, we're seeing, right, those two compounds kind of switching their partners. Same thing with the Na2CO3, excuse me, and CaCl2 reacting to form CaCO3 and NaCl. Well, we've got our picture down here, right? We have the two black characters and the two red characters, and then they switched partners, kind of switched dancing partners, if you want to think of it like that, for a black and red and a black and red. Hopefully that makes some sense. All right, let's look at some practice problems here. Now, this could be any of our types of reactions. So first one, we have MgO reacts to form Mg and O2. So this one, first thing to notice, we have one thing, one compound on the reactant side and two elements on the product side. One thing becoming two, it's going to be decomposition. Next, we have NaCl and K reacting to form Na and KCl. So for this one, we can notice single element on both sides and a compound on both sides. But that single element is kind of switching places for which element is by itself. So that is a single replacement reaction. C2H4 and O2 reacting to form CO2 and H2O. This is that special one we talked about in part 1, right, where we have a carbon and hydrogen plus oxygen, and then on our products we have carbon dioxide and water. Anytime those products are carbon dioxide, CO2, and water, H2O, that means it is a combustion reaction. All right, CuCl2 and MgCO3 reacting to form MgCl and CuCO3. Again, we got 2 compounds on both sides. They're kind of switching their partners. So we have a double replacement reaction. All right, and last but not least, we have Ca and S reacting to form CaS. So we have 2 elements coming together to form 1 compound on the product side. So that is a synthesis reaction. All right, that is it for our part 2 types of reaction notes. Hope this made sense. Remember, asking questions is one of the best ways to learn, and I hope you have a fabulous day.